All right, so welcome to this dev workshop, everyone. So this is actually our first developer workshop. So yeah, like this is our first time, so we're gonna try this format. And if you have any feedback, that would be very much appreciated. So the agenda for this workshop is to like build a very simple dApp together, which is like a token faucet. So there's like a lot of stuff that we need to like cover here, and we also want to take this opportunity to like get some feedbacks on our developer experience, like all the tools that we have built, and see if there's anything that we can improve, and if there's any like bugs or something, we will try to fix as well. So Chen is here, and if you have any questions, if I can't answer them, Chen will back me up. So yeah, so we will be here. So hopefully we can have a very nice, interesting conversation, like while we are discussing this, yeah, trying to build this dApp together. So the structure of this workshop, I have created this repository on GitHub. I just shared in the chats. I'll share it again. So I'm going to share this in the chat for the fourth time. So yeah, here is a repository. So maybe Wish can spend some time like setting up the dev environment and clone this repository, and then we can go from there. So I think Vlad sent out some notes before that we should install a few software like Docker Compose, and things like that. Have you guys tried to install them, or? If not, we can like spend some time trying to install all these tools.
What have we installed?
So, for example, Docker.
Oh yeah. I've installed the Docker.
Yeah, and Docker Compose, and
yep.
So we need an npm and Node, for example. I think that's pretty much it, and then we have like yeah, I think we could go from there. Like if we have Docker Compose, Node, npm, that's a good start. And also we need an extension wallet, or like a desktop wallet, but we can probably start from extension wallet. So if you search like Alephium extension wallet, yeah, there's like a Google Chrome version here. And also like there's a Firefox if you're a Firefox user. So I will do it together with you guys. Let me see. I will remove my wallet. And then I will go to the extension wallet. I'll go here. I'm gonna add this, add extension. And then I'm gonna create a new wallet from here. I'll give it some password. Then it should be like here. By default, it's on mainnet, but we're gonna switch to DevNet. But before we do that, let's clone this repository, like this dev workshop 01. So if you, yeah, maybe let's clone this, and what you should get is like this repository here, right? And then this default branch is 00 TxScript boilerplate. And this repository has like several branches, as you can see here. We will basically go through them like one by one and build up this step. The first step is to, the first branch is basically like a Next.js boilerplate, which has nothing related to Alephium, except that we have included some dependencies, and also there's like this Docker directory, which contains the Docker Compose file, and that's where we need to use like Docker Compose. I have already started this, but I'm going to tear it down and try to start again. Basically, it's as easy as like a Docker Compose up -d. If you have cloned this repository and have Docker and Docker Compose installed. How's it going so far? Have you guys cloned this repository and to Docker Compose, like something like this, and some other things. But, yeah. So basically, maybe I should clean up the data as well first. So I have a clean slate.
Hongjiao, it seems like a lot of people have issues using Docker to start the dev stack somehow. Like in the past, I have seen quite often as well. But for me, it was always okay. So I'm not really sure what's the problem.
Yeah, I actually primarily use Docker, so but for the limited time that I use the dev start, it actually works for me. Maybe I don't know. Is it because of
the also Docker is like used a lot in the industry, right?
Yeah.
So I think it's kind of very reliable and stable. But I always see a lot of people having issues with it. It's
yeah. Let's see whether today we have some issues. I'm gonna clean the data. So I have no data now, and then I do like Docker Compose upd, and then this whole. So the purpose of this is that we're going to start the entire stack of Alephium, which includes the Alephium foo node, the Explorer backends, and so on. And the reason we need to start these things is because, like, yeah, if we want to like compile a smart contract, deploy a smart contract, obviously we need a foo node, and for some of the things we want to do, like query some data, it's more efficient to do it from the Explorer backend, and also the extension wallet, or the wallet relies on the Explorer backend as well. So yeah, so let's see. Yeah, we don't need to download because the here we have specified all the images, and then when we do Docker Compose up, it's going to pull all those images to your local machine and stop them basically. Then all the configurations are already specified here, so you don't have to worry about anything. You just do a Docker Compose up, and then everything's up, and then we also set up some like a balance to some accounts as well. So it becomes a little bit easier for you to do testing a little bit later. So yeah, so if we have done the Docker Compose up, what we should see is do a Docker PS. We should see like everything's up, and then if we go to extension wallet here, right? We click DevNet. There's no account here. If we click account, maybe we should. Okay, so let's try to create a accounts in group 0. We have a concept called group. I assume that you understand that. So like you can basically create address in any specific groups in extension wallet. So you basically click group 0 and then you click create a new Alephium account. Yeah, then we have it on DevNet. So if you have already started the Docker stuff successfully, you should be able to see DevNet, the icon to be green here. Otherwise, it's going to be like red. So how,
I have a small suggestion. Sorry. Now you have 2 accounts. It's not so easy to remember like which one is the new one you create. So maybe we can rename it. Rename the second one is, for example, the dApp demo.
The demo, right? Yep. So we have a dApp demo account, and there's nothing. Okay, so how's it going so far? Let me know if you have any problems. This is not here, right? Yeah, so if you have started the extension wallet and then be able to, get to this point, that'll be great. That means that you have everything up and running, and then you have a working like extension wallet that we can interact with the dev later on. And for DevNet and testnet, we actually have a Faucet built into the extension wallet, so we can do like something like this. Then you get 1,000 elf on Scientist. I have them all installed and updated, but running Docker shows error. What kind of error did you get? Okay. Yeah. Do you mind to remove everything or? Hello, the fix. Do you mind to remove everything? Like, because it seems that you have other things that are that conflicts with this.
Sorry, what do you mean everything?
Okay, so if you do like Docker PS, do you see something? Something like this?
Yeah.
Do you see anything that you don't want to delete? Because otherwise I can give you a command to remove all the running.
Yeah, I can remove everything. What's the command? Wait, so what's the command to remove everything?
Like this.
Okay. It's removed some stuff, but not everything.
Okay.
DevNet Alephium 1 is running, and Alephium Explorer, pgadmin, and Postgres is running too.
you let me see. Do you get anything when you do Docker PS once a now? Or?
Yeah, the same.
Same. This is not deleted. Right?
So how do I stop them? The containers? I cannot remove it because some are running.
If you stop a if you have a container, you can stop it something like this. I think if I remember correctly. Then you can delete it by doing something like this. Or if it's started from another, if you have used Docker Compose before and you know where it is, you can do like a Docker Compose. Go to that directory and do Docker Compose. And everything here will be done. So
okay, I'll try the things.
Yep. So for those of you who have got into this stage, you can as I showed before, you can basically request some elf, and then you can get some elf here. I think 1000 should be enough. And basically, this branch contains really nothing except the boilerplates generated by the standards, like creates something like creates next app. There's like this command that you can create the boilerplate for Next.js application. So basically, there's like nothing other than that, except this Docker Compose thing, and also like we have added some dependencies in the package.json file, and that's it. So if we do like npm run dev, install first, and then do like a run dev, maybe I should run install. On dev, what you get is basically just this. Welcome to Dev Workshop. It's basically here we have a home, and then we have token dev, which basically is just welcome to the Dev Workshop. So if you're not familiar with Next.js, it's a very opinionated version of React to some extent. So like everything here, like you can use React stuff, but it has its own like structure for the project. So everything here in the page directory, it will be a page. Like if you have like foo bar .tsx, then you will be able to access that from here. It's like a pretty opinionated version of React, kind of. So here you have index, and that's why we when we load this, you get to this page because index, it's implicit right here. So that's basically the boilerplate. Because this token Faucet dApp, it has several components. One is the smart contract, and we also need a UI for it, and this is going to be our UI basically. How's it going, my scientist? Did you manage to get the Docker up, or? All right. Should we? So how many of you guys have gotten this far? Like, okay. I just assume that you have you have successfully started all the Docker stuff and then installed extension wallet. And if you get some help here, that'd be great. Then we can interact with the dApp later on. All right. So if you check out 0.1, this branch, get this this branch has, we can check the diff. Maybe we can do this contract open.route. So basically, the gist of this branch is that we actually now created this smart contract, not route, which is like a very, very simple minimum smart contract. Like not much to it. It's basically like a contract with a few fields in it. It has like it's a token, so it has symbol, name, small supply, nothing else, and then it has a few functions to return those things. That's it. And then, so what do we do about it? So we can try to compile it, actually. So we can do commands in the machine here. Compile, so we can do like npm run compile. This basically will, under the root project root, it will try to find the directory and try to compile like the source file in this directory. And this also requires the this Docker thing is up and running. Like basically the full node is up and running because the compilation actually happens there. We actually that needs to be up. All right. So what this command does is that it's going to generate a folder called artifact here. And then it generates this JSON file which has a definition of this contract, so almost like API, and then it has also generated some code that we can use to more easily like interact with this contract. I think to demonstrate this a little bit easier, in this branch we actually have a test case. It's called token .test.ts under the test integration directory. So I will try to like go through this test a little bit. It's pretty like straightforward test. So let's see. Initially, we need to kind of deploy. So this is an integration test, as you can see here. What it means is that we're gonna deploy this contract, and we're gonna interact with this. And there's another type of test, unit test, which is a little bit different, but we're gonna talk about integration tests for now. we will deploy this token faucet, and then we're going to interact with it in the test. So this token faucet class is actually the code that's generated when we run the compile. We can compile. This converts this like a smart contract into a TxScript, and it gives us a bunch of methods that we can, for example, deploy this smart contract and interact with this contract. So we actually imported this token faucet from this generated code. It's called the token faucet, and then we do a deploy. And deploy requires a signer, because obviously when you deploy stuff, you need a like private keys and so on to sign, because it's like a transaction. So you need a signer, and then this token wallet is also part of the SDK, and it has balance and so on, because when we do the Docker Compose up, it actually sets up one account, and that account is actually the provision was basically this test node wallet. We can use it in the test. Everything is kind of set up already. If you just use this, everything should work. Then we use this test node wallets to deploy this token faucet, right? And here you can see that it's one-to-one mapping to the field here, right? So when you deploy a contract, you want to give it the initial value of each of the field here, and then so this is quite straightforward. And then what's kind of interesting is that we can issue token for this contract. So token issuance in Alephium happens when we create a contract and we issue token together with when we deploy this contract. And the token ID will be exactly the same as the ID of the contract. So basically, this is how we issue tokens. And so when we deploy this token faucet, we give it some initial value, the fields, and also we issued the total supply, which is 100 amounts of token at the same time. And this token will be part of this contract, will be owned by the contract, basically. So after we have deployed this, we have the test, the SDK basically allows you to access the contract instance in the deployment result. So you can actually just get this token faucet from the result, and then you can actually call the method as if it's like a TxScript. I mean, it is TxScript. It's generated TxScript, but you can basically do like a method get decimal, like the same name as in here. And then you can get its actual value. It is the same as get to the supply. You get a value. It will be set up here. And we also support multi-calls, which I think Ethereum has it as well. Sometimes you want to get the a call function, multiple functions at the same time to reduce the network overhead. You can basically say, I want to call all these 4 functions at the same time. Then the results would contain these 4 things, and then you get a value for each of them, basically. Also, use this thing to get a state, which basically is these 4 things, and then you can I say it's quite nice to be able to work with the smart contracts like this. And also there's a way for you to get the balance of this contract. As we discussed a little bit earlier, we issued this amount of tokens. So if you basically, get a balance of this contract, so you can basically see the token balance for this contract is 100, which is like what we have issued, and the token ID is the same as the contract ID of this the ID of this contract. So, and when we deploy a contract, we have like a deposit, which is like 1 ELF. So every contract has a minimum like a ELF balance of 1. So this is what we have verified here. So we have a 100 balance of this token that we have issued, and we have like 1 ELF. So this is like an integration test, and like as we can see here, like the way that we work with the smart contract is quite nice, in my opinion. Because of the generated code, basically create a test case. And we used SDK, basically like the Web3 test to get the test wallet signers. And then we used the generated code, which under the hood also use SDK to basically interact with the smart contract. For the functions, we can get the states of the smart contracts. We can do multi-calls and so on. We can get the balance, and we can issue the token. That's the gist of it. We can issue the token as well. And that's basically the whole point of having a Faucet is to be able to kind of give out tokens, right? We issue this amount of token, and then we can basically get it later on in the app. Okay, so now we can run the tests, and we should be able to have successful results. Then so next up, let me see the handle. We have basic token. Okay, so now we're going to add some withdraw feature functionality. So we do git checkout 02 withdraw here. So what's added here is very minimum. It's basically a new mutable variable called balance, and then we have a new function called get balance, and then we have a new method called withdraw. And this withdraw basically takes a amount, and then we call a built-in function to basically, and also like the caller address. Whoever calls this method, his address will be here. And we call this built-in function called transfer token from self, because remember we have issued some tokens in this contract, and the token ID is the same as the contract ID. So we call self token ID to get that token ID that we issued, and we transfer this token of this amount to the caller. Whoever calls this will get this token, basically. And then we have this variable, a mutable variable, to keep track of this thing. It's generally like a good to have this thing to keep track of the balance of a token. You can also basically to calculate. You can also try to get a balance of the contract, but that's a little bit heavy. So yeah, so here we use this variable to keep track of that. And then when it comes to tests, we also update it a little bit accordingly. So we we added something about the get balance method, and that's not too interesting. But we also have tried to call this withdraw function. And okay, before we come here, we actually need to introduce something called a transaction script. So I'll keep these two things side by side. So here is the token route. This is the method that we have just created. to be able to call this thing, we need to. So this is if we call this method, it requires a transaction, right? And call these things, we don't need a transaction because it's just the read of the state of the contract. But here we need to modify something, and we need to get some assets from this contract to yourself. So this is like a transaction, and to be able to call this, we need to use something called transaction scripts. And in transaction scripts, we can call other contracts. We can do all sorts of things, and this is basically how a transaction interact with the other applications, basically. In this case, it does something very simple, which basically is to call this method. If you have a token faucet, you call the method with this amount, and that's it. And when we this is also under the contracts directory. So if you do npm run compile, this is also compiled. So if you look at artifacts, this is also compiled, and also in the script, in the generated code, you also have something called withdraw, which you can easily execute this thing, this transaction script. So I think it's probably a little bit easier to see in the token.test, in the test case, basically. So this is the thing that we have added in this branch. This is pretty much all we have added in the test. So what it does is that we get the initial balance of this token faucet contract. And remember, we have this token.12. We have this balance, right, from here. So we get initial balance of this. Then this is actually the generated code, this withdraw. This is generated from the withdraw transaction script that we have written here. So what we need to do is that we need to execute this thing. But it needs two parameters, right? So we need a token. We need to know which token faucet we're talking about, and we need to know what's the amount that we want to withdraw, right? Yes, and then we need some kind of a minimum a dust amount, because the UTXO has requires a small amount. So basically, this whole thing executes this extension. This transaction script, and then it triggers this method, invokes this method, and then what should happen is that the balance of that token in this token faucet contract will be reduced, right, by this amount. And then, since we call this transfer token from itself, it will transfer this amount to whoever calls this thing. And this is partly what we have tested here. We can also, we basically tested that the amount is reduced from token faucet contract by this amount. But we can also verify that the testnet wallet has increased this amount for this token ID. Something we can also verify here. But right now we only verified the balance of the token faucets. Okay, so which means that the withdraw function works, right? It's, it's the transaction script. Any questions so far? We have so we can have some method here, and if it requires a transaction, we need to have the transaction script. And I think visual like presentation of this is something like this. So in the transaction, like if you invokes, if it wants to call other smart contracts, you always need a if a transaction wants to invoke a smart contract, you always need a transaction scripts, and you have some inputs, and then you execute the logic in the transaction scripts, and then you generate some new output. And this whole thing is like a transaction, basically. All right. Any questions?
Hongzhao, did you explain the difference between contract and the scripts?
Contract and scripts, difference, yeah.
Compare them, like, here.
Yeah, so contract is it's like a, okay, correct me if I'm wrong, Chen, or if you have anything to add, but contract is it's almost like in object. It gets stored in it has its own state, and it has like a methods and so on. It's like a object-oriented programming, like it's an object, and we store it in a blockchain. So you can interact with it using method calls and so on. And then transaction scripts is something that you basically initiate the interaction with the contract from a transaction, and that's the way you interact with the smart contracts on chain. So you have to, so it's like an entry point to interact with the smart contract. Is that a good answer, Chen?
Yeah, I think so. Can you put them like together on the screen so we can, see the difference a bit?
So this is a transaction script. This is a contract. This is like an entry point. You in a transaction, like when you validate a transaction, if it has a transaction script, if it's not just a value transfer, like a token transfer or something, if it actually tries to invoke or interact with the smart contract, you need an entry point, almost like a main function, right?
Yeah.
This is like a main function for interacting with the smart contract.
Yeah, that's. I think that's a great way to say it. It's a main function, like in other language.
Yeah.
And the contract is just like a normal class.
Yeah.
So let's say that smart contracts can self-execute. Scripts cannot. I would say smart contract it's kind of like a public object that you can call it, you can use it, and a script is more like custom objects like spontaneous objects,
like one-off. You just have run it once, and then it was disposable.
Yeah. That's a great way to say that. Yeah, disposable. And a smart contract is always on chain unless you destroy it. Otherwise, it's always there, and anyone can call it. Of course, some of the functions they have owners, right? They can specify owners, and if you are not owners, you cannot call those functions. But in general, functions are public available, and is always there on the blockchain.
Yep.
So do we have to run the Docker instance every time, or can we just run like the same Docker instance for the DevNet and then just leave it running for the rest of them?
Yeah, you can have it running all the time. Like, yeah. In this case, we just want to like a demo from the beginning. But yeah, if you have it running, it should work as well.
Yeah, actually, I have been running for a long time, and I did not touch it, so I didn't see. Actually, I had an issue, and I just tried it a while ago, and I realized that I have issues with it as well, a disk space issue. So definitely, it's I think it's recommended that you run it actually for like you don't need to touch it; you just let it run. But of course, if you feel like it's using a lot of your space, sometimes you just shut it down, remove it.
Yep. All right. So, okay, maybe we should explain a little bit about the assetting, like these annotations. So this assetting contract basically tells, in this function, we will use the assets within this contract. Since token is actually part of it belongs to the contract, and we want to like give it out to whoever calls this function, right? So we need to like annotate this thing as true, assets in contract true, and this tells VM to basically load the UTXO for this contract. And then we have update fields equals true, and this basically is like another thing that we basically check, like, have you modified the mutable variable of this contract? And if you have modified, we want you to basically annotate this. And also we have another feature, like check its external call equals it's called like the external call check system, and the observation that we had is that when you have a public method that actually mutates the state, it's very dangerous to allow anybody to actually call it. So normally what you want is to basically check who is the caller. But in this particular case, since it's token Faucet, so everybody can call it, so we basically just need to like disable it. Yeah, that's basically the meaning of this annotations, and it's for security and so on. Anything to add, Chen?
Not much. I think in general, you just try it without using any of them, and then the compiler will actually usually reminds you that you need to use those annotations. So just get your hands dirty and play with it.
Yep.
And see.
All right. So I think maybe we should get to the next step. What do you say? So the next step, we didn't add any more new like features and so on. We basically just added some events and error codes and so on. So this will become pretty much the same like a contract code as the Next.js template thing that we have on our like GitHub repository. So this is exactly the same now. But since we have like grown from the bare minimum, you can like recognize the only thing that's different right now is the contract. So other than the comments, right? One thing that we have added is that we have implemented this standard interface, which is like a fungible token interface. This is part of the SDK. So if you want to implement a fungible token, it's probably a good idea to implement this. So I'll show you like what this gives us. Like it defines like a few standard interface, which allows, for example, like wallets to fetch those standard information such as name and symbols and decimals and so on. But also it added like implicit fields in the contract, and then it allows us to basically allows wallets and so on, like application, to basically guess, is this a fungible token or not? And this is one thing. We have extended a standard interface for fungible token. Also, we have defined event. yeah, if like this is quite common in smart contracts. We basically want to, if you have like another system alongside with the with the blockchain, and you want to monitor what happens with the smart contract, you can basically emit event from within the smart contract, and then you subscribe to the event stream of this smart contract, and you get a stream of events for this smart contract. Then you can do stuff. For example, like in this case, we have a withdraw events. Then in the withdraw function, we at the end of the function, now we added something to emit this withdraw. And then if you can imagine, if there's a like another system, you can subscribe to this event stream, and then try to understand who actually, like how many withdrawals, and like from who, and make a table of it, something like that. So that's the event. Yeah, you can also you can define the error code. And for example, here we added something like we can only allow the maximum amount to be no more than 2. And then if it's more than 2, the amount's more than 2, we throw an error with this error code, something like that. And this is an enumeration data type. That's actually pretty much it. So we basically added 3 things. One is the interface, fundable token interface. We added the event. We added the error code here, and we also have something called debug. And this is kind of a special like events, which only happens when you are in the dev, like a full node, a DevNet full node. And you basically, if you, for example, have a like an error or something, you can actually see this message in the log for the full node, and also like you can actually get it when you test the smart contract, writing type test for the smart contract. So this is kind of useful for you to like if you don't understand what's going on, you add a bunch of this debug thing in different places in the code, and then you can do print what do you call it, print line debugging. Yep. And again, to demonstrate what these things mean when it comes to like developing stuff, let's take a look at the test again. So this is the diff for the test. We basically only added some tests for events. Maybe it's easier here. So withdraw events here. This is the new. This is the new code, the new thing that we added in the test. So remember last time we basically did a bunch of withdrawals, and then we have checked the balance of the smart contract. But since now we have added this event, so we can also subscribe to this event, and then we verify like how many events have we gotten, basically. So we have this is also part of the like generated code, and use SDK on the hood. You can very easily like take the token Faucet and you do like subscribe with withdraw events. This method name is derived from the name of the event as well. And then you can specify, okay, like if I got a message, what do I do? If I have an error, what do I do? So in this case, what we did is basically just push events into this array. And that's it. So once we have executes the withdraw 10 times from here, we should get 10 events, basically. We sleep for a while. It gets 10 events. That's it. So, any questions? Just limit. Yep. Right. So if it's clear enough, we can probably move on again. Interface description. Yes. So right now, all we did is that we have a smart contract and we deploy it actually within the test case. We just call this directly, call this deploy function directly from here. But normally, like you want some kind of a process for, or like process for deployment. You want the deployment logic sometimes is complex. You want to be able to handle, like, define one set of deployments logic and then be able to reuse them across different network and so on. And you, for example, you deploy something, you also want to kind of want to use the results of the previous deployments. It's like like imagine it as several steps and so on. And also, you probably don't want to redeploy stuff. Like if you have already deployed it, you only want to deploy the stuff that has changed, right? So all these things, if you want to write it, it's kind of you have to take care of these details. And for us, we have developed the tools to do the deployment. So let's see right now if we check out the 04. Use deployment script. This basically only added a few, only added one deployment script. I'm going to show you what it looks like. Only 2 files. Only 2 files. So one file. So we have added the script directory here, and it has one file in it with prefix with 0. If you have like several steps, you basically create scripts with like a sequential number, like a 0, 1, 2, 3, like .ts, and then they're going to be executed one by one. So in our case, we only want to deploy the token Faucet, so we basically just create one here. Then we have defined some functions here, which will be like taken by the deployment framework or tools that we have developed. Here, it's kind of similar to what we have written in the test. It's like tests, you have to do something like this. And for the scripts, it's pretty similar. The assigner is actually specified somewhere else, unlike in test, which we'll get into a bit later. But the like issue token amount here, the initial field, these things, they are pretty much the same. So here it's actually easier. We basically just assume that there's a deployer which has all the details taken care of, like a network and like all these things, groups and so on. Then we basically just say, okay, just deploy this contract with this parameters, initial fields and the issue amount. That's it. Then the another piece of the puzzle is the configuration file. So this is the place where we define, for example, like what's the node URL, what is the private key for different kind of networks and so on. Because if you want, like, imagine if you want to deploy on mainnet, at least we can know like where should we, what is the private key for that we want to use to deploy, and what is the node URLs, and what are the common like variables settings that we want to pass into this thing, to this place, because like we probably want to issue different like token amounts across different kind of network. So we specify the issue token amount here, and then we can basically specify here, and you can imagine we can specify different value for this issue token amount for between like a testnet and mainnet, for example. But in the scripts, we basically just get this thing. I don't care what it is, and then we just this network thing is parents. It's hidden away from us from the script, and then we can basically just deploy this. So here we separate the configuration and then you can write multiple steps here. So once you have this, what you can do is that you run npm run deploy, which basically is under the hood. It always runs this CLI tool that is part of the TK, the Web3 thing. It basically just run deploy to DevNet. That's the default network. So if you do like a npm run deploy, well, basically pick the smart contract, try to build them, and then it tries to deploy to the DevNet. All right, so this is finished, and we could do git status. See that this file is changed, so it generates this .deployments.dev.json. Which basically contains the information of the deployed contract. Here you can see it has the transaction ID, the instance of the contracts, which has the address, the groups, and so on. And this will be used to we can later on load this into our application to interact with smart contracts. But this is something that it generates, and also it uses this to if it's already deployed and the contract hasn't changed, it doesn't redeploy. So it needs to take stuff down, remember what has been deployed before. So this is something that we, it generates. For DevNet, it's a bit tricky because for different person, the DevNet is different. It's all like something that runs on your network. But for mainnet and testnet, it's usually a good idea to check it in, so the application can use this directly. So this basically, after we add this, we already gain the ability to deploy them to testnet and mainnet, because as long as we have the private key to deploy the contract with, we just need to specify different network. Any questions so far?
So Hongqiao, I did not see the generated TypeScript file for the deployment. Seems. I think it should generate the.
Yeah, if you refresh, it should be here. The deployment file. This one, right?
Oh yeah. Because I did not see it in your Git status.
Because it's I already checked out I already committed into the.
Okay.
Yeah. So so the thing that Chen mentioned, this thing basically can help us to get the. For example, if you want to get the token faucets contract, and we don't want to care about the which network we are in, and we can use some of the methods here to get that. But we will see that later on, fairly soon actually. So now we have the ability to basically deploy this to DevNet testnets and mannets. We will try to deploy to testnets a little bit later, but yeah, right now we have the means to do it. Okay, next.
Yeah, I want to add one thing. So this may look a little bit complicated, but actually it is not. Is the SDK actually provides the scaffold for the whole deployment process, and you can basically copy this file, and then tune it a little bit for your own use case. So the prototype is there, is here for deployment. You just need to change a little bit for your own use case.
Yep. All right. So now we have like smart contract side of the things kind of semi-ready. We probably should spend some time on the UI side. And the first thing that we probably want to do is to have a way to kind of interact with the contract, which is to have like authentication. Like the application has to know like who you are. Yep. So we have a, okay, so maybe it's easier to just look at the effect. We want to basically have like a button to authenticate ourselves using the wallet. And then from that point on, we have some way to interact with the smart contract and so on. And but also the smart contract knows who we are and so on, stuff like that, right? So next step, we want to add this button to the Next.js boilerplate, like a very minimum thing, so that when we click it, we will be able to see like, okay, what is our address, basically. So this is very small amount of code. Basically, in the app.tsx, initially it was like this. We wrap it with this Alephium connect provider, and we hardcode the network to be devnet and the address to be 0 for now, and everything else is the same. So basically, this is like React context thing. It's like a way for you to pass some global variables across all the dependency, like a component tree and so on, because we want to have stuff like a signer, like your information globally accessible from all the components. We basically have it, we wrap here, we wrap all the components with this provider, and then in the index.tsx, we basically added this button. This button is also part of the SDK, or like a Web3 React. It's like a React component. And we also have this code. We have this use accounts hook to access users' current accounts. If this account is available, then we basically show the address. So that's all the logic that we have for this branch compared to the one before. So to recap, we have wrapped this like component with this provider thing. This you can actually custom the themes and so on. But you can also specify like what network and like address like the group. If you don't specify it, just it doesn't really care. But if you specify it, in this case, it's only it requires the account to be like devnet group one, basically. And if you don't have it, then the wallet, for example, will show that it doesn't have this or something. So then you have to create one. So this is first we wrap this, and then we added this button, and then we use this hook to say, okay, yeah, if you have account, then we show the address. That's it. So if we run this right now, Yeah, so basically adds this button here. And this button, if you click, it pops this thing up, and then you can pick like Tesla wallet or extension wallet. In this case, I will use extension wallet, but Tesla wallet should work as well. Then it picked the group one DevNet here, and then since I have this address available that meets this criteria, so this is good. I will do connect, and then it shows this address. Any questions so far? So this is basically a very easy way for us to integrate the wallet into the dApp. From this point on, you will have some hooks, and you have some some functions that you can use to interact with the dApp and so on. Any questions? Now you can basically disconnect, and then this is going to be gone. So all right. Okay, so maybe this is good. Then what do we do next? So since we have access to the accounts and the signer and so on, like the information that we need to interact with the chain, the next natural step is, since we have already deployed the token faucet contract in the DevNet, on the DevNet, we can basically try to show these information, right? Like, because in the test we have already gotten the already called the methods and tried to get the value of each of the fields. We can basically fetch those information and display on the web page, right? That's basically what the next reflects display contract info. This probably is this is not too much code either, so I can probably explain a little bit. We have defined, so this is actually the place where we used the deployment generated code that Chen mentioned a little bit earlier. So this the fact that we have deployed, written the deployment scripts and so on, SDK basically took that and generate this deployment file, which contains, for example, a load deployment function here. And then we can, if we know what the network is, for the network, we basically say, okay, if you have this environment variable, we use it. If it's not, we default it to like DevNet. If you know what the network is, you basically can just load this token faucet contract directly from this deployment generated code. Then, if you have this token faucet, you can get the address and so on. So depending on the network, it will be different, right? Yeah, it will be different. For DevNet, since we have already deployed, we don't specify anything for this environment variable. This should be fetched from basically this file, this development.dev.json that we have generated using the npm run deploy. So we have created this config, and use this deployment thing to load this information from the deployment information. Yeah, like the information that we generate from deployment. And then we basically, so this is the thing, right? And then we basically pass it into the token dApp. component. And here, what we did is we basically just showed the ID, the group, the balance. The ID is actually in the config that we just fetched from the deployment file. Group is the same. And the balance is a little bit interesting because this could change, right? This if you picking some like a token from this faucet, the balance would change. So basically, and balance is actually the one of the field in the smart contract, and we have a method to actually get it. It's called get balance, right? What we can do is that we can write a hook here. We can say, okay, yeah, like whenever like basically like fetch this balance. We call this because we have the token faucet, right? We can initiate this class that we can interact with the token faucet using this address, and this is provisioned through this deployment file. Right now it's devnet. And then we instantiate this token faucet, and then we can call this method and get balance and so on, exactly the same way as we did in the test, right? In the test, we did the same. So in here, we can do the same. And then we set this value to the, we set this value, and then we display it. So it's quite straightforward. We basically added this table here. ID column, group column, and balance. So that's it. So if we run the this again, the contract has been deployed to testnet. Okay, did I run it on testnet? DevNet. Yep. So we basically, we have this table and we have ID, the group, and balance. So ID of the token is this. We have group 0 and we have balance 100, which is like the initial value that we set for the contract. So this is, like how we can display this information on the web page using a combination of like the Web3 React thing that gives us some hooks or signer information that we can interact or fetch information from the chain, and the deployment thing information that we got from the deployment, npm run deployment. And the nice thing about the deployment framework is that if we want to switch this to testnets, right, that's what we're taken care of automatically. So we basically just need to deploy to testnet and then change the environment variable to be testnet and then run it. Then everything is exactly the same, except that it's actually pointing to testnet now. So that's kind of the workflow. Okay, any questions about? All right, okay, so let's move on. And so next natural step is to add this withdraw thing, right? Withdraw method. We have the withdraw method. We just need to like call it from the website. So basically adding another like thing input here. What's interesting is, so I can show probably expand a bit on the code. We basically add an input here, and we have, so then we have when we press the semi token, we basically submit. This form will be submitted, and then we basically call this restore token function. And if you look here, it's exactly the same as what we used in the test. So this is the generated code for restore transaction scripts. This is exactly the same as what we have. Here it's exactly the same, right? So basically, we created this function that wraps this thing, and then in the when we try to withdraw it, we basically call this function, and we also did something to do some visuals for transaction. We have set the ongoing transaction ID, and then we basically show some kind of a transaction status for this. And transaction status is we have a hook for this as well. So yeah, it's you can basically use this hook to when the transaction status change, you can basically display like yeah, what's the, you can display it basically. And that's it. We that's the only two things that we have added in this branch. We basically, number one, called this withdraw transaction script using the generated TxScript class, same as test. And two, we basically showed the transaction status, and we have like hooks to help us to do that as well. So let's probably try it, right? So if we do, then it should pop the extension wallet up, and then we click sign. Then the transaction status instantly gets confirmed. This is DevNet. It will be a different story in the testnet. And then you have notification. Yeah, we have some problems. Yeah, issue with the token, but we get two. This I was just aware of it before the presentation or like the workshop, so we need to look into this. But we get this two token from this Faucet, and then if you get more, it's gonna just keep decreasing, and you get more from your wallet, and this gets decreased. The balance gets decreased, right? So yeah, that's it. Then we get this token Faucet. Any questions so far?
Hongqiao, maybe we can speed up a little bit. I think it's getting a bit too long. I'm not sure. How do you think about it?
Yeah, I think we are almost done because this is already like pretty, yeah, it's already done, right? When it comes to features and so on.
Yeah.
The next thing is basically just deploy to testnet, and we have already have the means to do that. So I'll just quickly show you what is changed. Basically, we have hard-coded the DevNet here, right? We basically change it to like configurable. This network is taken from a variable, like environment variable, and then the group index is configurable as well. And that's basically all we have. And if we want to deploy, if you look at the file, we need to have a private key. So what we need to do is to export a private key to something. And if you want to use this, you can go this key, you can go to demo key, and then you go here, here, right? And then you explore private key. Then you click this, put it in here. And then what you need to do is to run deploy testnet deploy. So I'm not gonna run it, but this is basically how you do it. And then you will generate a deployment testnet.json. This is the thing that I deployed like a little bit beforehand. You can basically use this already. You can do like the next key of public network equals testnet, and then you can do like a run dev. And this basically will start this towards testnet. Maybe we don't have anything on testnet. Okay. Yeah. I will try to add something here. But yeah, so if I do this, I'll try to do this. So now it tries to connect to like DevNet group 0, right? And then if you click connect, then this is the testnet token faucet. So if I do 1 or something, right now I probably don't have any balance. Oh yeah, okay, maybe it works. Maybe now it has balance. Yeah, okay. Anyways, this will basically this runs towards the testnet, and it will send a token to my testnet account. I think we can probably pretty much stop here. We have another branch basically talks about the unit tests. I think maybe testing in general deserves another like workshop or something. I think we have already covered enough. Maybe. What do you say, Chen?
Yeah. I think there are like way more contents in this first workshop. We'll see how to kind of do it in a different ways in the future workshops. This one is a bit too overwhelming, I think, for
yeah, too much info.
Yeah, too much info. But in general, I want to, as I said a bit before, it looks like there are a lot of things, but if you get your hands dirty playing with the templates, you don't need to change too much to have some new features. You probably just change the smart contract like for your own purpose, and then you just compile and deploy it. Pretty much like that. So the templates has almost everything. You can reuse it for new projects.
Yep. And we have like in the CLI, we have a command to basically Scaffold a example project, which is based on Next.js-templates. This.
Yeah.
Yep. So yeah, if you want to like quickly start working projects, that's probably the best way to do it.
Yeah, go to the Next.js templates instead of using this workshop. We have a dedicated repo for that. And also we have another repo is called examples. Rough examples, I think. And let me also send that one. The rough examples has some more advanced kind of examples right now. Includes all the examples like DEX, NFT, bridge. That can give you more like production ready examples if you want to see how like more production stuff looks like. You can try those.
All right. Any questions, you're welcome to ask.
Or any suggestions.
Or any feedbacks and so on. Like what maybe there's something that is kind of rough when it comes to developer experience. yeah, we will fix this yeah, this token display issue later on.
If you have like feedback later on you want to give, you can also reach out on Discord. Just drop a message on Discord. Last I want to say, if because it's our first one, we want to actually give some presents, kind of to to thank you for joining the workshop and to give the feedback. So yeah, feel free to share us your address on Discord. You reach out to me or Hongqiao on Discord. Share us your address. I'm not sure what we are going to give as a reward, but we are going to give something. So we kindly ask you to provide us your address, and then we're going to do something.
Talking about the email address or the wallet address.
Oh, wallet address. Wallet address.
Yep.
Yeah, if you reach out to us on Discord, we know like how to reach out to you in the future, right? So.
Yep. Cool. If there's no more questions, yeah, thank you so much for joining the workshop. That was first one. So yeah, if you later on have any feedbacks, please let us know. We very much appreciate it.
Awesome. Thank you guys for joining. Thank you, Hongqiao, for the great presentation. And let's go.
No worries. Yeah, let's go. All right. See you guys. Have a nice weekend.
Bye, everyone. Ciao.
Bye.